These are the study guide answers for ELR 3.1 on the Unit 3 study guide. The first question is asking us what is the acceleration of an object if it takes 20 seconds to change speed from 200 to 340 meters per second. For each of these questions, we're going to be using the same equation over and over again, but I think it's a good habit to rewrite the equation and then substitute and solve. That's the habit that I'm into. I would recommend that you start building that habit, but this is how I would solve it. So for this question, we start with the equation, which is acceleration equals change in velocity over change in time. So when we start substituting these things, the first one's relatively simple. It's telling us our time is 20 seconds, and it's telling us these two velocities. So remember from class that in order to find the change in something, you have to take the last thing minus the first thing. So like what were you doing at the end minus what were you doing at the beginning. We went from a speed of 200 to 340. So we're increasing our velocity. We need to end with a positive number. The only way to do that is to go 340 minus 200. If we did it the other way around, we'd have a negative number, which would mean that we were slowing down, and this object is speeding up. Okay, then we put that over time. It tells us that it takes 20 seconds. When we plug that into our calculator and solve, we get 140 divided by 20, and that is going to be 7. Now let's not forget what we're solving for. We're solving for acceleration, and those units are meters per second per second. By the way, I've noticed on a few of the previous tests that people are a lot of times forgetting the units. This is a good idea for putting on your note card if you need to add this equation, which it'll be on the test and on the wall, but if you want to add this equation and then add in the units so that you don't forget what everything is in, so that when you're done solving, that's a second, when you're done solving, you can check to make sure that you have the right unit. For number 2, same type of question. We're going to be doing acceleration is change in velocity over change in time. And Derek is the driver of a train. The train's moving at 10 meters per second. He applies the brakes, so automatically we should be thinking that we're going to be dealing with a negative number here. And it slows in 20 seconds, so that's our time. And we have a final velocity, so the 1.5 is what we end at. And it again wants to know our acceleration. So we're going to start plugging stuff in. In order to find a change in velocity, we need to take the last thing we had minus the first thing we had. So the ending velocity was here, 1.5. And we needed to subtract it from whatever we started with, which was here at 10. And then we put it over how much time it took, which was 20. So if we do 1.5 minus 10, we're definitely going to get a negative number, which is what we want. And when we do that, we get 8.5 over 20. And when we throw that into the calculator, we're going to get a negative 0.425 meters per second, or meters per second squared. The last one is a little bit more challenging because it's asking us for one of these velocities, like how we did on the Derek question. It gave us both of the velocities. This time we're being told all the other pieces except one of the velocities. So this one's a little bit harder. We're still going to be using the exact same equation, change in velocity over change in time. And we're going to go very carefully and make sure that we pay attention to our signs also. So it says Matt's new puppy named Waffles has this acceleration, and we have a starting velocity, but we want to know how fast were we going, so that sounds like a velocity, after 6 seconds. So we're looking for a final velocity, so when we're all done, when Waffles is all done running. So just like before, we did the final minus the starting velocity. So when we substitute, we don't know a final, so we're going to leave that as our variable, velocity final. We don't know. But we do know a starting velocity, so we're going to subtract 2, because that's how you find the change in velocity. That's what goes on the top of this equation. It may look funny at first, but it's going to allow us to solve this problem. And then we put it over our time, which told us 6 seconds. It also told us that this was equal to, I'm kind of doing this backwards, I'm sorry, acceleration was given to us, and it told us the acceleration was 1.6, so 1.6. So this is our equation that we're dealing with right here. Well, in order to solve this, we're solving for velocity final right here. We need to get it all by itself. So first thing we're going to do is multiply both sides times 6. So we're going to simplify this over here. Velocity final minus 2, that's what's left over on the left side, is equal to 9.6 when I put that into my calculator. And now we have velocity final minus 2 equals 9.6. Now we need to add 2 to both sides. So we're going to get velocity final is equal to 9.6 plus 2 is 11.6. Now a lot of people, whoops, that's a 6 right there. 6. A lot of people will be tempted to put meters per second because you're just getting into the habit of that's what all these questions are asking me about. But be careful, we were solving for velocity. So we need to make sure that we use the right unit, meters per second. This is a velocity, not an acceleration.